My name is Amrita Bhatnagar. I am from CSE Department of Akgec. Today I am going to explain a very good topic, Introduction to Memory Management from the subject Operating System. These all are the outline of the lecture. First one is the Introduction to Memory Management. Second one is the role of memory management. Third one is the goals of memory management. Next is the degree of multiprogramming. What is the meaning of degree of multiprogramming? We will understand. Then we will understand what is the memory management techniques. Different type of memory management techniques we will see here. And next one is a memory allocation method. Okay. So firstly we will understand what is the meaning of introduction to memory management. What is memory management? Memory is the important part of our computer that is used to store the data. Its management is critical to the computer system because the amount of main memory available in a computer is very limited. At any time, many processes are competing for it. Moreover, to increase performance, several processes are executed simultaneously. For this, we must keep several processes in the main memory. So, it is even more important to manage them effectively. So, we know that the operating system is used to interact between the hardware and the software. So, this operating system have many different type of functionality, and the memory management is the one of the most important functionality of the operating system. So, you can see in this diagram, you can see here this is the user program and this is the layer of the user interface, which is a layer of operating system also you can say, and system call. This one is a system call and this is known as a overall, this is known as a operating system, which is used to give the interface to the user programs. And these all are the different type of functionality of the operating system, like file management, memory management, process management, network management, power management. So these all are the main functionality of the operating system, and this is the hardware. So to provide the interface between the user and the hardware, we need a operating system, and operating system perform many different tasks here, and the memory management is the main task of the operating system. So we'll in this lecture we will understand what is the use of memory management and why it is required. Memory manager is used to keep track of the status of the memory location, whether it is free or allocated. Memory manager permits computer with a small amount of main memory to execute programs larger than size or amount of available memory. The memory manager is responsible for protecting the memory allocated to each process for being corrupted by another process. Memory managers should enable sharing of memory space between processes. Thus, two programs can reside at the same memory location although at different times. So, memory actually we have a small memory, but we can execute more than one programs with the help of this memory. So, you can see here if we have a memory like this, and these all are the main four partition in the memory. So we can say that we can have four programs in the in this memory at a time. So if this memory can be efficiently managed, then we can put more programs in this memory and it can be used more efficiently. So this is the main work of the to use the memory efficiently. This is the main work of the memory manager. It will track all the free or allocated memory. If we have P1 in this space, what it means, this memory is allocated. If we have P2 process in this memory location, what it means, this memory is allocated. And you can see here these all are the free memory location. So we can say the memory management or memory manager work is to keep track of all the allocated or free memory so that it can be efficiently allocated to different processes. Goals of the memory management: maximum CPU utilization, minimize response time, protection to user, program and OS, efficient utilization of memory. So these all are the main goal of the memory management. If we have manage our memory efficiently, then CPU also utilize better in the better way. Degree of multiprogram. Degree of multiprogramming means what it means, if we have, this is the main memory and one part is allocated in the main memory for the operating system OS, And this is the a second part of the main memory, where we can have different type of processes. For example, we can keep here 4 processes or 4 programs. What it means, the degree of multi-programming will be here 4. So, maximum number of programs we can have in the memory, that is the degree of multi-programming. The degree of multi-programming describes the maximum number of processes that a single processor system can accommodate efficiently. Fine. There are some factors affecting the degree of multi-programming, such as primary factor being the amount of memory available to be allocated to executing processes. So, this is known as a degree of multi-programming. Now, the memory management technique. Then we will start with the memory management technique. The memory management technique can be classified into 2 main categories. First one is the contiguous memory management scheme, and second one is the non-contiguous memory management scheme. So, memory management technique can be of 2 types. First one is the contiguous. Now, contiguous another is again divided into 2 parts: multi-programming with fixed size partition and multi-programming with variable size partition. So, we can have for example, if this is your memory and now it is divided into fixed partitions. Now, we have divided this memory into 4 parts without knowing that what is the size of our processes. Then it is known as a fixed partitions. Or if we have this partition in the variable size, then this is known as variable size partition. But this is a contiguous memory management, where we have already fixed partitions for the processes. Multi-programming with fixed static size partition. Multi-programming with fixed partition is a contiguous memory management technique in which main memory is divided into fixed size partition, which can be equal or unequal size. In fixed partition, the memory is divided into fixed size chunks, with each chunk being reserved for a specific process. So, if we have divided our memory into 4 parts, what it means, this is we can have 4 processes in our memory. Now, you can see this diagram. With the help of diagram, you can understand what is a fixed partition. You can see here, this is the main memory. We have a main memory, and first partition is given to the operating system. This is reserved for the operating system, and the second part is used for the different users processes. So, you can see here, we have here 4 partition. So, what it means, we can have 4 processes in this particular memory. So, in each partition we can have only 1 process. This time you can see here, if we have the first partition size is 4 MB. You can see here, this is the first partition size is 4 MB, and we have one process P1 in this memory area, and the size of this process P1 is 3 MB. What it means, it will reside in this memory area, but the remaining part will have 1 MB will be leftover space in this partition. So, you can say that this memory is wastage of the memory, or it is also known as a fragmentation. It is known as an internal fragmentation, because the size of the partition is 4 MB, but the process reside in this partition is 3 MB, and 1 MB is a leftover space in the memory, and we don't have that much small process also, so that we can put in another process here in the memory. So, in this way, you can see here, this is the partition 2. Again, this is the partition have the 4 MB memory area, and P2 process reside in this area again, and this is this process have a 3 MB space, and 1 MB again leftover spaces. In this way, 4 partition we have, and in each partition we have 1 MB wastage of memory. You can see here. So, this is known as a 1 MB internal fragmentation. So, you can see here, we have 4 MB leftover memory here, and if a particular process P5 wants to come into the memory, but we cannot allocate the memory to this P5 process. Why? Because we don't have memory in a contiguous manner. You can see here, 1 MB in the first partition, we have 1 MB in the second, 1 MB in the third partition, and 1 MB in the fourth partition we have, but we don't have this partitions in the contiguous manner, so that we can allocate this process P5 to the memory. This is the main disadvantage of the the fixed size partitioning, and this is known as the external fragmentation. This is because we cannot allocate the P5 into the memory, but we have this this much amount of memory left over in the memory. So we can say that we can't execute it even though there is a 4 MB space available, but not contiguous. So this is so because we don't have contiguous memory here, that's why we cannot allocate P5 into the main memory. This is the main disadvantage. So we have understand here what is the meaning of internal fragmentation and what is the meaning of external fragmentation here. Now the disadvantages of fixed size partition, which we have already discussed this technique, fixed size partition. We have first disadvantage is internal fragmentation. If the size of the process is lesser than total size of the partition, then some sizes of the partition get wasted and remain unused. This is a waste of memory and is called internal fragmentation. Second one is the external fragmentation. The total unused space of various partition cannot be used to load the process even though there is a space available, but not in the contiguous form. Third one is a limitation on the size of the process. If the process size is larger than size of the maximum size partition. For example, when in the previous example we have seen that if the partition size is 4 MB, but if we want to insert a particular process which have the size of 5 MB, then we cannot allow to put this type of processes or big processes in this partition, because we have already fixed size partition here. So this is the another disadvantage of this fixed size partitioning, limitation on the size of the process. If the process size is larger than the size of the maximum sized partition, then that process cannot be loaded into memory. Therefore, a limitation can be imposed on the process size, that is, it cannot be larger than the size of the largest partition. Fourth is degree of multiprogramming is less. In fixed partition, the degree of multiprogramming is fixed and very less due to the fact that size of the partition cannot be varied according to the size of process. So, degree of multiprogramming means we can put less programs in the main memory. So, these are the main 4 disadvantages of the fixed partition. So, we can have next is the dynamic size partitioning. In this dynamic size partitioning, what will happen? Initially, RAM is empty and partition are made during the runtime according to the process need. Instead of partitioning during the system configuration, the size of the partition will be equal to the incoming process. The partition size varies according to the need of the process, so that internal fragmentation can be avoided to ensure efficient utilization of RAM. Number of partitions in the RAM is not fixed and depends on the number of incoming processes and the main memory size. The operating system maintains a table of free memory blocks or holes, each of which represents a potential partitions. When a process requests memory, the operating system searches the table for a suitable hole that can accommodate the request amount of memory. So, in this case, we can see this is the example. You can see this is the example of dynamic partition. So, firstly, what will happen? We will not divide a particular memory into the fixed size partition. Firstly, for example, P1 wants to come into the memory, then it will take the 2 MB here and it can store in the memory. Next, the P2 will come and the size of the P2 will be 7 MB, then it will accommodate in the next level of the memory. Then next P3 will come and 1 MB will be allocated to P3, and next P4 will come and 5 MB will be allocated to the process. So, in this way we will not partition the memory before the processes will come. When the process will come, it will take required memory area, and then again another process will come and it will take required memory area. In this way, dynamic partition will be done. So that we can say that partition size and the process size will be same here. That's why internal fragmentation will be reduced here. So we don't have any internal fragmentation in this case. The advantages of dynamic partition is that no internal fragmentation, no restriction of the degree of multi-programming. We can have more than one, more than 4. For example, in the fixed partition, we have only degree of programming can be of 4 because we have partitioned the memory into 4 parts. But in this case, we are not partitioning the memory. We can have more degree of multi-programming here. No limitation of size of the process. Again, we don't have limitation for the size of the process in this scheme. So, this is the better scheme from the previous scheme. Disadvantage of dynamic partition is difficult implementation and external fragmentation. In this case, again we cannot remove the external fragmentation because when the process will complete and it will send it will remain the holes in the memory, and then again we will this scheme will suffer from the external fragmentation. Now, memory allocation methods. For both fixed and dynamic memory allocation schemes, the operating system must keep a list of each memory location, noting which are free and which are busy. Then, as a new job come into the system, the free partition must be allocated. For example, you can see here, this is the memory, and these all are the partition of the memory, and you can say P1 is allocated here, P2 is allocated here, and these are the holes of the main memory. So, when a particular process P3 will come, so how we can choose a particular hole to insert the P3 process. So, we have here for algorithm for to allocate the P3 to memory allocation for the P3. First fit, what it means, when P3 will find out, will we go to the first available memory location. In the best fit memory allocation, the size matters. If the size of the P3 is 2 MB, then P3 will be inserted in that hole where the size will be the close to the 2 MB. Next is the worst fit. It is the largest fit or memory allocation where we have largest memory allocation block will be allocated to the P3. And next fit memory allocation, in this case the process will be allocated the next block of the memory allocation from the previous allocation. So these all are the 4 memory allocation method to allocate the memory into the free allocated places. Okay, so this is the main introduction of the memory allocation technique. Thank you.